Okay, so when I graph it from standard form, we talked about that this is standard form, and again, I'm just going to, the first video messed up, so I'm just going to write this on here. It's ax plus by equals c. Basically, the x and the y are on one side, the constant term, which is just the plain old number. It's what we call the 6 is a constant. It's a plain old number. It's on the other side. So what I'm going to do is I'm going to graph it using my x and y intercepts. So I'm going to put graph using intercepts. The book kind of tells you about it, but it may not word it quite this way. If I want to know where the x-intercept is on a graph, it's the place where the graph crosses the x-axis. So let me draw a little, let's say I have a line down here. And it does something like this. The x-intercept is right here. It's where does the graph cross the x-axis. If that crossed it, let's say 1. Let's say it's 1. Wouldn't that be the point? X is 1, y is 0, right? So what do you notice about the y there? It is 0. At an x-intercept, y is always 0. So if I want to find the x-intercept so I can graph it, because that would make this easy to graph, if I could find the x-intercept and the y-intercept, I could just put them on my graph and I got my line. I only need 2 points. If I want a third point, it makes it better, but 2 points is all I got to have. So if I want to find x-intercept, what I do is I set y equal to 0. On intercepts, if it's an x-intercept, the opposite variable is 0, so y would be 0. If it's a y-intercept, the opposite variable is going to be 0, so x would be 0. That's what you're going to see me write down here in a minute. So let me take the equation, and instead of writing y down, I'm going to set y equal to 0. Look at this cool little equation I get to solve here. It's so easy. 2x plus 0 is just 2x. 2x equals 6. Divide both sides by 2, you get x equal 3. Oh, my x-intercept is at 3. So I'm just going to draw a little tiny graph down here. So on my x-intercept, right now, if you could use your graphs. You know you're going to need one for each one. This is 29, and I think the first one is 25. You might want to number your graphs that I gave you. 25, 27, 29. This would be the third one. You could put a point at x equal 3. That's actually the point 3. X is 3, y is 0. I want you to get used to writing it as a coordinate point, 3, 0. I want you to write x equal 3, but then I want you to write it as 3, 0, just because I have a hard time getting people to do that when they get older, and you always have to do it when you're older. They always say write it as a coordinate point. Okay, so the x-intercept gave me 1 point. We talked about while the video was off that I could have, since I'm setting y equals 0, I could actually cover up the y with my finger, and I had the equation 2x equals 6, which is what I really wanted to solve there. It can be that fast, okay? What if I want to find the y-intercept? Let me write it in a different color here. So now if I need a second point, I could find the y-intercept. So the y-intercept, if you look down at my green graph where I was playing around at the beginning, let's say it's right there. Let's say that's -1. Isn't that the point? X is 0, y is -1, right? So if that's 0, -1, anything on the y-axis is going to have an x equal to 0. So at your y-intercept, x is always 0. So if I want to find my y-intercept, to find it, set x equal to 0. And I am out of space. So if I'm gonna set x equal to 0, let me take the equation. I'll write it over here in like a bright green so we can see it, just to kind of separate it. 2x plus y equals 6. But if I'm going to set x equal to 0, that just becomes 0 plus y equals 6, because isn't 2 times 0, if I stick it in there, which is kind of hard to see, 0 plus y equals 6. I could have covered the whole x term up with my finger or my hand or whatever, and I would have the equation that I got to solve there. And actually, I don't even have to do anything to it. There's not even any dividing on this one, because it's just y equals 6. There's my y-intercept. So y equals 6, that's my y-intercept. So let me go graph it down here on my blue graph where I was trying to keep up with my real graph. If y is 6, 1, 2, 3, 4, 5, 6, let's say it's right here. I've got my y-intercept, I got my x-intercept, bam, I got my graph. It's that fast. Okay, so 31 is the last one you have to do that's like this, and it's 4x minus 3y is 12. It's in standard form. It's not solved for y. In other words, the x and the y are on one side. And so let me go ahead and draw my graph over here where I'm going to put it. If you already did it, you can just check your work. Here we go. Remember, you always want to label your x and the y. I didn't on the first page because it was hard to get it in. The graph was so tiny it would have looked like a big messy blob anyway. Okay, so what I'm going to do when it's in this form, I'm going to find my x-intercept. And how do I do that? What do I set equal to 0? Y. You set the opposite variable equal to 0. So it's 4x minus 3y, and I'll put a 0 in there, but I could have just as easily taken my finger and covered up the whole y term, because 3 times 0 is 0, and I end up with 4x equal 12. And when I divide both sides by 4, what am I going to get? Yep, x equal 3. 12 over 4 is 3. So I have an x-intercept, and it's telling me, hey, your x-intercept is 3. Go to x equal 3 and put a dot on it. Put your point down. That's actually the point 3, 0. I'm going to write it over here in red. That's what I graphed. It is a point. It's not a number. It's a point. It has an x part and has a y part. So now let me go find my y-intercept. To find my y-intercept, it's where the graph's going to cross the y-axis, but I can find it by setting what equal to 0? X, the opposite variable. Set the opposite variable of the intercept you're trying to find equal to 0. That's kind of the way I always had to remember it. I was trying to memorize what was what when I was y'all's age, and it just didn't make sense. So if you think it's the opposite one, so if I'm setting x equal to 0, I could plug the 0 in for x. Or I could just as easily have taken my finger and covered up this part of the equation up there, because 4 times 0 is 0, right? So it's going to go away when you plug the 0 in. And I end up with 3y equals 0. If I try to solve that, how do I get y by itself? Yeah, divide both sides by 3. And y is equal to 0. Okay, so on the y-axis, I'm at 0. That's not right. Oh. Yes, I did that wrong. Let me go to edit. I was supposed to set the variable equal 0, not the number equal to 0 on the end. I'm sorry, yeah. So going back, let's do that y-intercept again. I'm supposed to set x equal to 0, and when I was talking and writing, I did some stupid stuff, which normally happens sometimes when I'm doing that. I'm setting x equal to 0, but I needed to have the whole thing still equal to 12. I don't know why I did that. It was just too much in one time.
I thought that I was like, okay, I get this. I think I'm like...
And then I messed you up. And then I messed you up. I messed you up. So we set it equal to 12, not the whole equation. You're just plugging x equals 0 into the equation. I just messed up there. Because I'm like, that can't be. That's not right. I could tell what the answers were before I did all the algebra. Okay, so that's going to be 0 minus 3y is equal to 12. If I'm going to get y by itself, now what do I do? By negative 3, right? So sorry about that, yeah. You just set the variable equal to 0. You don't change the number on the end. It was just one of those arrowhead things I did. 12 divided by negative 3 is negative 4. So my y-intercept is negative, let's see, x is 0 because we set x equal to 0, and y is negative 4. Ignore that bright green dot on the graph. That would be right here is where it should be. And when I connect them, I should get something that looks like that, though. Well, on the iPad, I missed it.